All right, so we are talking lesson 6.4, conditional probability. This is probably something you guys have never seen before, so this is brand new. And you have one formula today, just one, for you to memorize, to know, and to know how to use. All right, that's our goal for today. All right, so conditional probability. It's different because it takes into account a piece of given information. All right, so you use this when you actually know something before you calculate the probability. All right, so this is your formula, straight up. All right, this is your formula. So when you're looking at this formula, let me kind of break this down for you. First off, this right here, vertical line, this means given. Okay, that means given. So how I read this is the probability of A given B. The probability of A given B. So that means you know that this is already true. All right. You're given that B has already happened. You know it's true. And now you want to find the probability that A happens. All right. So then this is your formula. The probability of A given B is the probability of A and B divided by the probability of B. The probability of A and B happening divided by the probability of B. All right, so let's go ahead and practice using this formula. Any questions before we get started with our practice problem? Okay, all right. Let's go into this example about tattoos. All right. I don't know if anybody has a tattoo, so I'm not going to guess. I'll randomly pick somebody to read. Let's see, Matthew. Matthew, can you read this one for us?
The article chances are you know someone with a tattoo and he's not a sailor.
Sorry, that's typo. That should be do you know, but yeah.
Included results from a survey of adults aged 18 to 50. The accompanying data are consistent with summary values given in the article.
All right, keep going.
Assuming these data are representative of adult Americans and that an adult is selected at random, use the given information to estimate the following probabilities.
Awesome. Okay. So chances you know somebody with a tattoo and he's not a sailor. Okay. So back in the day, tattoos were not as common, all right? Only, certain segments of people would get tattoos, but now it's become a lot more popularized. So anyone might have a tattoo. You don't know. I have some tattoos. You don't know. I'm not going to tell you where. Ha. Mystery. All right, so question, what is the probability that a randomly selected adult has a tattoo? All right, here's your table. We have people with at least one tattoo or no tattoos. We also have age categories, ages between 18 and 29, age from 30 to 50. But the question is, what is the probability that just a randomly selected person has a tattoo? All right, let me call on Sophie. Sophie, what do you think? Oh, Sophie, is your mic working? Oh, unmute yourself.
And what's the probability that a random selected person has a tattoo?
Yeah, what numbers would you use?
18 and 6.
18 and 6. Okay, so 18 and 6 are people with at least one tattoo. So how many people total have a tattoo?
24.
24. And how many people are there, period, in the survey?
100.
So what's your probability?
Oh, 0.24 or 24%.
There you go. All right, done. So they didn't really, specify what age group they were looking at. So we're looking at the totals, right? So 24 out of 100. Perfect. Okay, so that's your traditional typical probability. Now, I want you guys to contrast that with this question. What is the probability that a randomly selected adult has a tattoo if they're between 18 and 29 years old? Now, this is different because you are given something, right? You are given that they are between 18 and 29 years old. So that's why this is a conditional probability. This is a conditional probability. All right, so if I want to find that, you can use your formula. You could also just pull out the numbers from the chart. We'll just go ahead and use the chart since it's pretty clearly given to us right now. But I'm going to look at the probability of, or the number of people that are between 18 and 29 and has a tattoo, right? This is my numerator in my formula. So Angelus, how many people have a tattoo and are between 18 and 29?
18.
18, good. And Angelus, how many people are just between 18 and 29? Oh, sorry. Oops. Well, there you go. Yeah. All right. 50. Good. Good job. So yeah, that is your ratio now, right? That's your fraction. So you have tattoo and 18 to 29 over just 18 to 29. So the second part is always your denominator. All right. So we have 18 over 50, which gives us 0.36. Okay. Questions on that? All right, let's try another one. This one. What is the probability that a randomly selected adult is between 18 and 29 if they have a tattoo? Now, notice the wording here. It's a little bit different because now this is our condition. This is what we know. We know they have a tattoo, and we now want to figure out what's the probability they're between 18 to 29. All right, so pull out the numbers you think you need and set up your fraction. All right, and let me call on Ethan Carver. What numbers are you using for this one?
Well, 18.
Good, so
And,
still 18, over. How many people just have a tattoo? Over tattoo.
uh, 24.
Yeah, there you go. All right, so 18 out of 24 gets you 0.75. Yeah? All right, any questions on that? Okay, all right. I'm gonna have you guys practice this a little bit. So pull out the other handout and let's do a little practice.